Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com. So today our focus is innovative technologies to improve sustainability in the chemicals industry. So it's driven by government regulations and climate change, industrial circularity, manufacturing efficiency, reduced emissions, renewables, advanced materials, and bioplastics are all front and center for both industries and consumers. Energy, digital, automation are a triad to achieving sustainability goals and leading to disruption in the industry where new technologies are competing with and displacing older technologies. Industries in the future will be more interconnected and interdependent. And in fact, it's already happening in desalination, green hydrogen, the steel industry, paints, coatings, and resins. So here with me today is Bhaskar Sinha, Director at the R&D Innovation Lab, and Nidal, Ghizawi, R&D Director for Process Automation with Schneider Electric.
Thanks for having me today.
Thanks for the opportunity.
Okay, great, guys. So thanks so much. So in a recent episode of Schneider Electric, we talked about sustainability and ESG and how it was front and center in organizations. And specifically, they were emerging circular business models for those who make digital technologies. And by the way, folks, you should feel free to jump in at any time as we engage in this discussion. But what can you tell us about today, the drivers for the chemical industry? Let's start with you, Bhaskar.
Thank you. There are several drivers for the chemicals industry, key among them being the change in the consumer behavior and the regulatory pressure driving towards sustainability. Innovation in technology is driving development of new chemicals and processes, improving the efficiency of production and reducing costs. There is focus on circularity, reduce emissions and energy usage, and also there's increasing usage of renewables. There's also a shift in supply chain dynamics happening due to availability and cost of raw materials going up over the last 2 years. We also see chemicals industry expanding because of sustainability and circularity. Traditional industries such as water, metal, steel, chemicals, and the upcoming industries from energy transition are getting interconnected and unlocking new value.
Yeah. Okay. So let's talk a little bit about this Schneider Electric's view on the triad of energy. And certainly Schneider Electric is a company that makes digital and automation. So how is this working to achieve sustainability goals? And first of all, what is this triad of energy, digital, and automation, and how is it working?
At Schneider, we believe the triad of energy, digital, and automation is key to achieving sustainability goals. Achieving energy efficiency through optimization and use of renewables would reduce emissions. Digital, which also includes artificial intelligence and machine learning, offers the opportunity to identify the key areas to drive efficiency and cost, provides better insights, and supports human to make better decisions. Automation helps in both supporting digital as well as running systems with minimal or no human intervention, thus driving maximum efficiency and throughput.
Nidal here. I just want to add that these three elements of the triad, the energy, the digital, and the automation, are very interconnected and interdependent as well. For example, the automation part and how you do it can be a strong enabler to digital and energy. Future next generation open automation and control systems allow seamless integration between the IT systems, which are usually on demand or just in time, and OT systems, which are real-time systems, to enable quick and efficient applications of analytics and machine learning models at the enterprise level that can target to improve the plant energy efficiency, availability, reduce emissions, etc. These future open automation and control systems can also help deal with the issue of the e-waste as well, which is a significant global problem. It is estimated that approximately 50 million metric tons of e-waste is generated each year. This figure is expected to increase in the coming years as more and more electronic devices are produced and discarded. If we look to the butterfly diagram on the circular economy model, you will notice that for the technical cycle, the inner loops, which are about share, maintain, reuse, and refurbish, represent the core elements and the most sustainable part of the system, as it involves maximizing resource efficiency, keeping resources in use for as long as possible, and minimizing waste. Future open automation and control systems emphasize using of these inner circles to achieve sustainability and reduce the environmental footprint of these systems. Let me give a few examples. First of all, these future open automation systems enable manufacturers to seamlessly connect their IT and OT systems to monitor and control their processes. These systems also help reduce energy consumption, improve the overall efficiency of the plant operations more effectively. A second example is resource conservation. With open systems, many aspects will be handled differently, like, for example, high system availability. One common approach to achieving the high system availability in a traditional DCS or distributed control system is to use a physically redundant architecture in which multiple components are used to perform the same function, and the system then can automatically switch to a backup component if the primary component fails. With open automation and control systems and using IT-based concepts like system orchestration, a whole new approach to achieving high availability can be envisioned and implemented that can be used to optimize the use of raw materials and other resources, helping manufacturers to reduce waste and minimize their environmental impact. The last example here I want to talk about is supply chain optimization, where open automation and control systems can be used to optimize the flow of goods and materials throughout a supply chain, helping to reduce waste and improve efficiency.
Right. So industrials are not known for, or at least traditionally, they have not been known for adopting newer technologies, and perhaps that's changing. So let's shift to you, Bhaskar. How are the new technologies competing with and displacing some of those older technologies?
The newer technologies coming from process intensification, artificial intelligence, machine learning, renewable energy, biotechnology, 3D printing, etc., are driving towards sustainability, higher efficiency, and reduced costs. Some of these technologies are not mature yet or not cost effective, but continuous research and investments along with government regulations would ultimately make them mainstream options in the very near future.
One thing to add here, specifically in relation to automation, a paradigm shift is really happening in terms of how we will be able to design, build, and operate plant automation and control systems. Advances in the telecom, IT, and other industries as well as the work of other organizations such as the Open Process Automation Forum, OPAF, NAMUR, and the universalautomation.org, they are moving the industry towards a software-defined or centric industrial control system solutions. There is an evolving consensus that platform-independent, software-driven solutions can enhance flexibility for end users and allow the customers to benefit from portable control applications that can be developed and deployed across their fleet, irrespective of the underlying hardware, basically decoupling hardware from software. In addition, this will allow for the development of advanced software applications to be offered as a service in the OT domain. We are really just hitting the tip of the iceberg here.
Interesting. Okay, so you mentioned a couple of times about being more interconnected and interdependent. Can you explain how Schneider Electric is helping customers in this area?
We see the interconnect of the industries happening. As an example, the steel industry to reduce its carbon emission is looking at using green hydrogen as a reducing agent. The green hydrogen needs water, and that comes from the desalination industry. The steel industry today also uses a lot of paints and coatings. Again, we are seeing that this particular industry is venturing into paints and coatings to support internal consumption and also to serve the external markets as well. At the same time, we see the paints and coatings industry is looking at consolidating its value chain by venturing into resin manufacturing to reduce its risk from raw materials. Another example, if you look at the mining and the metals industry, they need a lot of water for the processing of the metals, and this water would come from the desalination industry for all those industries along the coastal areas. We also see that to achieve sustainability goals, the metals and mining industry is looking at carbon capture, where they would look at capturing the carbon and then reusing it, which will produce ethanol and methanol, etc., which are again getting into the chemicals industry. So there are several other examples of such interconnects happening in other industries. Because of these interconnects, it's becoming more vital to make systems open and more modularized to handle the complexity. Schneider supports openness through universal automation and helping systems to become smarter through digital and automation.
Yeah, let me elaborate on this automation system openness. I mean, as Bhaskar indicated, this openness of the automation system is key to addressing the significant complexity of the interconnected industries of the future. We at Schneider Electric believe in this open future so much. And as a result, we have gotten engaged in multiple initiatives that would enable this vision to come to life as soon as possible. Again, let me share a few examples here. First of all, the first example on November 3rd, 2020, and in collaboration with a large number of partners, we established universalautomation.org, in short, UAO. First of all, what is universal automation? Universal automation is the world of plug and produce automation software components based on the IEC 61499 standard, which solves specific customer problems in a proven way. Just as the IT world has realized the benefits of open operating platforms, now it's the industry's turn. UAO is the nonprofit independent association that was established in 2020 to manage following shared source principles. This reference runtime implementation of the IEC 61499 standard that we in Schneider had. UAO promotes flexibility, portability of code, interoperability across different vendor platforms, as well as IT/OT convergence and the plug and produce approach to automation. And this is achieved by the different vendors implementing the same runtime on their hardware platforms. UAO members come not only from the vendor side of the business, but also from the user side. We need both, obviously, the vendors launching universal automation offers and the users demanding the technology from their suppliers. The second example, again, because we believe in this collaborative approach and universal automation so much, Schneider has launched its own first universal automation offer in 2020, the EcoStruxure Automation Expert, in short, EAE. AEE is a new category of software-centric industrial automation software system. It's an innovative approach to manage the complete life cycle of the automation and control system. At the highest level, it enables our customers to drive to 100% engineering efficiency, be ready for 100% operational effectiveness, and now be 100% future-proof. The third example is we in Schneider are a founding member of the Open Process Automation Forum, OPAF, and are engaged in many of the committees working under OPAF to develop this standard of standards for future open process automation systems. The last example I want to talk about here is about our Middle East open process automation testbed that we have established at our Saudi Schneider Electric Innovation and Research Center to collaborate with interested customers and partners on the development, testing, validation, and demonstration of key technologies and applications that are critical to make this future of open automation and control systems a reality. We are using this test field also to drive for field pilots with customers and create the new culture and awareness needed, the new way of doing automation based on the IEC 61499. We are making good progress here. We are in advanced discussions with some key customers in the Middle East regarding field pilots of such open automation and control systems that go beyond oil and gas application to other market segments such as chemicals and desalinations.
So recently at an ARC industry forum, I had an opportunity to present on something very, very similar. It was open digital twins, which is taking a lot of these same concepts, Nidal, to the enterprise, how 3D technologies work together and plug and play concepts. And in that presentation, I actually presented a slide from Don Bartusiak from ExxonMobil back in 2015 when he introduced this concept of open process automation. And one of the things that was interesting was I contrasted what was said in 2015 with today presentations on open process automation, and the number of logos is considerably larger. So you talk about partners, both technology suppliers and asset owners across different industries. So for sure, there has been a big shift in the adoption of open process or open interoperable systems. But let's just talk a little bit about some of those challenges, because I think companies still struggle a little bit with how to justify making investments and getting rid of older technologies and older protocols like Modbus technology. So Bhaskar, what do you think? What are some of the challenges the industry is facing?
As I mentioned earlier, technology readiness, the cost of new solutions for the end customers, and the implementation of those new technologies impacting the current supply chain are the key challenges faced by the industry.
I will only add that these challenges that the industry are facing are too big to be addressed or handled by one company alone. For us to be able to effectively address those, we need ourselves to open up, like some of us may never have done before, in order to collaborate and partner to create the future together.
So we're coming to the close of the podcast today, gentlemen. Do you have any last thoughts for our audience today?
The changes we see in the future will be capital intensive and disruptive. No single player can bring in the change effectively and quickly. The collaboration between industry, academia, startups, research bodies, and government policymakers are key to unlocking the value in the future. At Schneider, we work very closely with our customers, OEM, startups, universities, research bodies, and government institutions through a co-innovation model to unlock the value faster and effectively.
From my side, we no longer have to live with many of the constraints we have learned to accept for a long time. We believe the industry's future is wide open, and we would like to shape that future together with you. We encourage industrial operators, vendors, and end users to adopt the universal and open automation systems approach to drive sustainability and efficiency.
Well, that's all the time we have today. Thanks to Bhaskar Sinha, Director, R&D Innovation Lab, and Nidal Ghizawi, R&D Director for Process Automation with Schneider Electric.